data structure for file data structure in terms of the database concept. Okay, so when we create, for example, after the modeling, like some ER model, then the relational database schema diagram, like this, and finally you decide to create the table. Okay, for example, employee table. How can you create it? Using DBMS software. So, for example, in our exercise lab, we selected Oracle database. Oracle database is a software to manage and organize a database based on relational model. Okay? And another example of such a DBMS is Informix DB+tree. Those are the relational database management system. So when you create a table like the employee, it has the employee ID and name and so on. This is my presentation. Inside the DBMS Oracle database, they will not create such a thing. Instead, DBMS use what? Specific file structure to create a table. Okay? For this file structure, for table, for database, we learn. So let's say this is the file, emp.dat file. So actually we don't have to worry about how the file data structures are organized because of the three schema architecture. Actually, the database design focus on how to design, how to build a conceptual model of your database. You don't have to worry about inside what's going on inside the DBMS. But if you know such a files, actually that is the main part of the database in computer science on a graduate level course. Okay? Actually, designing itself is not a big problem. You can easily understand. Then the main part is how to organize them. Based on that, what is the master? When you apply this program, so what did you think about the master? What does that mean? It's just a degree or a certificate to get a better job? No matter what do you think, but I believe the master is master of this subject, master of science. In other words, after you get the MS, Master of Science degree, you can teach the other. Because it's a master. Like the martial art, how do you call your teacher? It's a master. Because he masters everything, so he can teach it. He or she is qualified to teach someone else. Also, you can advise. Okay. So if you do not believe yourself for a Master of Science, please do not graduate. Just kidding. Then what is the PhD?
That's just a research degree.
Master also requires research. But at least you should master a given subject. Computer science, but based on that, PhD, doctoral student, to get the PhD degree, you should have your own area, your own approach. Can you understand? Yes, master, you should understand all the existing subject and you can teach others. On top of that, if you are pursuing the PhD, PhD means when you get the degree, which means it is recognized as you are the only one in this area, specific area. Okay? It's your idea, it's your own methodology, your thing. For example, I know every algorithm, every subject in computer science, so I'm the best one. But that doesn't mean you can get the degree, PhD degree. Okay, that's the different thing. Okay, so the reason I discuss about such a file structure is actually that is the main part to understand how the database is organized, how the DBMS system manage the data, create the data, manage the data, and the organization. So this is the file. When you create the table, this emp.dat file will be created, but we don't know how it is organized. Okay? What we know is just a schema, column name, attribute name, and data type. That's it. So when you create the employee table, it will create a file structure. Okay? This file consists of what? Block. Okay? It's called a blocking. Okay? One file consists of many blocks. Why? Because of performance. Okay? A block is a basic unit, smallest unit to process, to transfer. Even though we need only one record in a block, entire block will be processed, returned, cached, read, write. Okay? For better performance. Then, this is called a blocking. In other words, for example, if we are using 112 byte data, okay, one record is the 100 byte. One row, one data need 100 byte. How many records can be inserted in a block? How many? 5. Okay? 2, 3, 4, 5. So 5 will be inserted in the next block. It doesn't have to be continuous. Okay? So sometimes it can be the block is over here, next block is over here within your file system in your computer. Okay? It doesn't matter. So you can create the file. There are 3 different types of the file for this. When you create a table, one is ordered file, another one is a non-ordered file, third one is what? Hash. Okay, what is ordered? For example, if we insert the data, record, or tuple, or row, it's the same meaning right now. I explained that we learned every term, but probably you understand these are all the same. This is, for example, employee ID and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This file is sorted by the employee ID. That is the ordered file. Non-ordered file is, for example, this is just 10, 1, 2. There is no order. Okay? Which one is better? We don't know. Sometimes ordered file, it's easy to find the data using binary search. The complexity is log n based on truth. Okay, we already discussed, you already learned in your algorithm class. However, in terms of management, whenever we need insert the data, delete the data, update the data, what do we need? Sort the data, which is the most expensive operation. In other words, takes longer time. What about non-ordered? You don't have to worry about it. So whenever you insert the data, append. The problem is it takes a long time to search the data, brute force way, and over to complexity. And hash, it doesn't need the sorting the data, but we use hash function. But because of the nature of hash, there are several problems like the collision, overflow, and so on. So if you can address those problems, hash is another choice. So this is the file structure for database that we discussed before. Okay?
What is optimistic in this? What is optimistic way? I mean, what that?
You want a true story? No DBMS used this one. This is just the basis, like to understand the multiplication. So you should know the addition, something like that. Okay. To do the better programming, you do better start from the C or C++. So right? So basic. Even though you do not use a C++ or C program, you do better know definitely that is a basic program. So this is a basic file structure. So what is a real story? So that's a good question. For example, Oracle, Informix, DB+tree, each DBMS has their own file structure. As we discussed, this DBMS is nothing but software, which means, so what is a software? In computer science, it's a file structure. Everything is a file structure. So that means Oracle defined their own file structure to manage or organize the data. In addition to this basic idea. At that time, they consider convenience and performance. So, for example, Oracle, when you create a table using Oracle, do you know where your table is created? No, you don't know, because of pre-schema architecture. But inside, when to create a table or any database object, you should have the username and password. So somebody already create your username, like the database administrator. When database administrator create a database user, like this is a good example, room. Each user should have the default room where a user can create a table, like this room. I'd like to make my own space. I'd like to keep all the student information. Please give me the space. Then database administrator assign the one room for each user. Whether or not you realize you have in your Oracle database. Sometimes you need more room. Then you can ask the database administrator, give me the permission, another room. Then you can create a table on specific table space. That is called the table space in Oracle. The table space is a kind of big room. To create this one, database administrator already create the room or table space. Just like who built this building. We don't know. Probably some builder or administrator already built this building. Then, if registrar office allow me to use this room, I can use this room. Just like that, table space is created by the database administrator. Then, what really happened when database administrator create this table space? This is what, for example, 2 big size of table space. What happened in operating system? It's a file. For example, this is the abc.table space. abc.dat file will be created. Size is 2 GB size file. This is a file. In other words, inside the file you can create a table. This is their own file structure. Okay? Then I would like to create an employee table. So Professor Lee said that when we create a table, it will create one file. Yes, it's the same. Using this table space file, we can create the table. It consists of blocks. So it looks like the grid. But each one indicates block. Okay? So, for example, this one will be used for employee table. Let's say this is 1K. So how many blocks to be divided by 1K? Will be number of blocks. You can use this block. Then, this is so this concept includes the basic, order, non-order, fashion, variable. Then, not only blocking idea, actually Oracle, not only for Oracle, most of the commercial DBMS systems use this concept, that is extend. Extend means, so I need a 5 block. 1, 2, 3, 4, 5. Whenever I access the data in employee table, I need to access this one, this one, this one, this one, this one. Or YN. So scatter. What if the continuous block? Which one is faster? Contiguous block or scattered block? Definitely, it's a contiguous block is faster. So, however, not always we can have such a big chunk, right? Sometimes, as you can see on your Windows system, why don't you take a look at the defragmentation or fragmentation tool? Is even though I have 1 gig free space, it's just divided very small pieces. So to address that problem, we need a contiguous block, but not always we have. So we Oracle define extent. Extent is a group of contiguous blocks. Not only one block, like this one. 1 chunk, 2 chunk, 3, 4, 5. Manage as many as block possible. We allocate, Oracle allocate. That is extent. So table has number of blocks. Actually, this block is number of extent. Extent is contiguous blocks. Okay? Then each block also has not only for the data, it's a header information. This block belongs to employee table, and this is the address, blah blah blah. There are some basic information in the header. Okay, the other can be used for the data. This is for real story. At that time, there is no concept about order, non-order, actually non-order. There is no order, because if we consider order, it takes a longer time. Okay? Then we have additional file structure, table space, extent, and header information. DB2 has similarity. So IBS has a similarity. And SQL Server has their own, in addition to basic file structure. Okay? Then, the problem of this file structure is, what if? So we have ordered file. So let's say this one used ordered. So how long it takes? Log to n. So in other words, it's monotony increase. That means if we have more data, it will take longer time to search the data. What if 10 millions of data? What if 1 trillion of the data? Yes, it's possible. Nowadays, very large database are everywhere. So this ordered file cannot be acceptable for fast processing. So do you have any idea to address that problem? Anyone? There is one way to speed up. That is called cache. What is a cache? The temporary storage. In other words, whenever we read the data, we put this one into the memory. So when we search the data, when we read the data, do not go to hard disk drive directly. First search the memory. But it's limited. Why? Memory is limited. We cannot put all the data into the memory. Definitely. So this order the file is not enough. So any other way? That is called the index. Okay? To speed up for the search. So index, what is an index? Dictionary term, not the database, not the computer science. What is an index? Sorted. Alphabetically sorted. What? Or information. Data. It's a guide to find something specific information. I do not know the definition of the Webster or the dictionary.com, but probably something like that. Everybody knows what index means. In computer science, it's almost the same, but more structured. Is there anyone who has a textbook? Any textbook? That's fine. So this is a textbook for data and computer communication. So I try to find OSI 7-layer information. So how can we find? So if you are lazy to find it, just search from the first page and next page until you can find the OSI 7-layer. Or if we are a little bit smarter, you can go to contents. Then find the appropriate chapter like the local area network. No, I don't think so. Data communication, basic architecture, and so on. Then go to the chapter page, then find the data. If you are the smartest student, you can go to the end of the book. There is an index. Then what is this index? This is the what? Alphabetically sorted what?
Words.
Keyword. Okay? And not only keyword, they are sorted, and also you can see the page number. So, for example, OSI 7-layer packet, for example. So packet header is a 42. You can directly go to the page 42, then find the information about the packet. It's the exactly same concept in database. So, packet 42. This is the keyword, this is the page number. So you can, this is the index entry in your textbook, right? So you can find the information about packet that you want very, very fast. It doesn't take a time, less than a second, right? What about database? I'd like to search employee tool. How can you find? Without using this one, we can use binary search, cut in half, cut in half, cut in half. It takes a logarithm and based on 2. If we have such a, for example, 2 this is the address, for example, FF. So, if you know the address of the data 2, so if we can find something, so this is the 2 and FF, then we can go to this address, get the data. Exactly same thing. So instead of using such ordered data or non-ordered data, so use the file structure with non-ordered or sometimes a hashing file. Then we can use index. Then what is this? This is called index file. So if you are asked what is an index in computer science, what is an index in database? Answer is index is a data structure. For what? For what? When do you need index? For sort? For search the data very fast. So fast searching. That is the only reason why we need additional. Definitely, if we need an additional structure, that's overhead to manage. But we need the fast search. So this is index structure. Index is also file. This is a file for data. This is a file for what? Index. So index is a file, another data structure for fast searching. Okay? Then, since this is a file structure, their organization format is different from this. Right? So how different? It has index data, indexed data, or key. Sometimes it's called the index key, plus address or pointer. Any index structure has the same format. Data, index data, or indexed key, plus address of real data. Okay? Then, since also this is the file, as I said, it can be blocking. How many blocks? 1 block, 2 blocks, 3 blocks. Each block has, for example, 512 bytes. 512 bytes. 512 bytes. Inside the 512 bytes, it has many. This is the entry. Key index, key entry. Many index key entries are here. They should be sorted. Since they are sorted, we can easily very fast search the data. So result of the searching data, index entry is a pointer. So next we can get the data very fast. That is the topic of last chapter of this semester, index file structure. Okay? Then, depending on how it is organized, there are different types of index. Like we have ordered file, non-ordered file, and cached file. Just like that, I do not explain how to organize this file. I just explain the index key entry. This is the basic. In addition to that, depending on how to organize this one, there are many other index structure. We will discuss about this today and next to the remainder of the semester. Last week will be for your presentation. Okay, before we move to chapter 18, we have a couple of more things to discuss. This storage area networks first. So when you create a database, so for example, what is this? Computer. It's a server where you can create the data or whatever. Work on the program. What is this? It's an operating system. Definitely you need the operating system. Then finally we can install the DBMS and learn the program and create your database. Also, computer has secondary storage, hard disk drive. Definitely it has a file system, so it can use the storage to keep the data. What happens when you create the table employee? Based on this idea, what happened? What happened? What does DBMS do? DBMS will create file for this table, employee table. This is the employee file. Okay? Then manipulate the data. We have another system. This is for computer science. This is for electrical engineering. Then it has the same operating system, DBMS, and storage. Then create the table, files. Okay? So we are running two different DBMS. Then the capacity of this one is only 10%. The other is 90% are free. But unfortunately, the growth of the computer science department is already full. So we need a space. What can you do? Can you use this space? No, because it belongs to a different computer. Okay? So we need to add this one. That frequently happen in the industrial, the IT infrastructure. Even though we have the totally many free space, sometimes we cannot use it because they belong to dedicate to the specific computer. Is there any way to address such a problem? In other words, so can we maximize the utilization of the space. That is the idea of a storage area network. Why don't we have one big storage in our computer environment? Then, in this case, this is called a local hard disk drive. How do they connect it? For example, using ID or SCARS or sometimes USB drive. They are connected. If we are using centralized hard disk drive, we need to connect. At this time, we are going to use a fiber optics. Fiber optic is very, very fast. Also, it allows very long distance, 10 to 30 kilometers distance. It doesn't have to be local or very close. It can be 30 kilometers away from the server with the same speed. And also same, using fiber optics, we can connect. This is called storage area network. For this, you should have the specialized storage. It's called the storage box. So for example, EMC Corporation provides a symmetric storage box, or IBM Sharp is the brand name of such a storage box is from IBM. Okay? This storage box actually consists of a bunch of hard disk drive that you have. 5-inch hard disk drive or 3-inch hard disk drive. It's the same thing, but it not only for the hard disk drive, it has the fiber optic device and some other memory for the storage box, and you can connect many hard server to share this benefit. For example, this is 10 terabyte. I need a 5 terabyte daytime, but at night we need only 1 terabyte. Dynamically change the allocation. If some system needs more space, we can allocate more and take out and dynamically change it. Okay, so this is the storage area network. Another concept of such a thing is NAS. Network NAT. This is the device name. NAS. Network Attached Storage. That means in our IT environment, suppose that we have a bunch of storage and bunch of server, 100 server and 100 storage. So I'd like to share such a storage for many server. Okay? So for example, we have server, 100 server. And storage. Some of them are big, some of them are small, some of them are big, small. But sometimes for server A, computer science department would like to use this one, and also this one. And sometimes this one may use this one. It will be very, very complicated. Storage area network is kind of integration. But here, it's a schedule. At that time, we can put something device that is called a NAT. NAT device. NAT device is almost quite similar as a router and network. It's kind of a router for storage network. So we can attach, and also attach the server. Then when you find the storage, it's kind of routing. This device shows how to access the attached storage. At this time, you don't need the fiber optic. It's just connect using the network. Okay, this is called the NAS. But nowadays, the storage area network is more popular than NAS. Another concept in such a storage is the iSCSI. So this is the example of SAN storage area network configuration. We have only one storage box, and we can use the storage box from many different servers. we can dynamically change the allocation depending on the requirement. NAS is a network that is a storage like this one. We have the specific device in the among them and connect many server and many storage. Yes.
For a company like Google, what kind of storage?
A computer is their own architecture. Is based on a bunch of the not big size of computer. Is a medium sized computer, so which is based on the files. Okay, but they manage their own file indexing. Okay, it's not relational database. Their own database management system in terms of file. Okay, so Google has their own architecture for their computing. SCSI is based on the SCSI. Some of the older computer has the SCSI device, which is for the storage. So transfer speed is quite small. So 50 megabyte, around the 50 megabyte, and the benefit is you can attach the 15 the storage at one time. Nowadays, even the USB is much faster than such a SCSI. So SCSI is the SCSI disk controller, but it's based on the internet protocol. But I never used that. I just heard from the textbook. So that's the only thing I know. This is a real example of the storage configuration. So like this one is the SAN, storage area network. We have two boxes of this, and this is for SCSI. This is another box. They are connected through the fiber optics from many different servers. This is a database configuration that I manage. So 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 Oracle database, and 1, 2, 3, 4 information database, and we have the DB2 somewhere. Then the final chapter is for indexing structure. So we already discussed about what is an index, and index is a file for what? Fast accessing the data. Okay, so it has a bunch of index key entries that consist of the value, field value or key value, as well as the pointer or address of the real data. Okay, depending on how to organize such an index key entries, there are different data structure for indexing. So we will discuss about it first. We can use this one. There are two different types of indexing structure. One is dense index, another one is non-dense index. Let's use. So why don't we use this is an employee. Okay, so I create an employee table, which means the DBMS create the employee.dat file. Okay, it has employee ID, and so this is the ordered index. Ordered by what? Employee ID. Then definitely it uses the blocking. So let's say blocking factor is a 5. So divide by the 5. How can you search the data?
Voicemail received.
How can you search the data? You can use binary search because it's an order. The problem is the more data you have, the longer time it takes. Okay? To address the problem, we need something new structure that is index. Then How can we make the index for this? Idea is simple. This is a block, which means when we search the data, so we have only one block. Suppose that we have one block, 1, 2, 3, 4, 5. How can you search the data? Using binary search, you can search the data. Cut in half, cut in half. However, this is one block. In other words, we need only one I/O. Then copy this data into the memory. In the memory, to search the data within one block, it doesn't take a longer time. So we can almost ignore searching time within a block. So in other words, if we can find a block where the data is in, that's it. It doesn't take a time to find the data within a block. In other words, why don't we make the index of the block? First, 1. So let's say address is 0, 1, 2, 3. This is the address of each block. Okay, then 1. Index data entry 1 is in what? Where? 0. Why don't you make the same index as I show you in the textbook? Number 6 is in block 1. Number 11 is 2. Number 16 is 3. These are address, this is the value, index the value. We don't have to index all the data. Why? So for example, when we search number 3, first see where the 3 is belongs to. Less than this, finally this one. Then this block is in number 0, so go to this one and find the 3. This is a index. If they belongs to one block, it's totally fine. Otherwise, make a different block. This is called index, especially if used primary key. So this is called primary index. How can you make a primary index? Because they are already sorted. So we can take the first value as well as the is address. Then make the entry. Next block, same thing. First value and address. First value and address. First value, address. At this time, this is called anchor. Anchor data. Because it's a representative entirely. That this is the anchor. So using anchor data, we can build the index, primary index. At this time, do we use all the data for index key entry, or do we use only part of the data? Which one? Part of the data, only 1, 6, 11, 16. So this is called non-dense index. On the other hand, if we use all of this as an index key entry, that is called dense index. Okay? So some of the index are dense, the others are non-dense index. In this case, this is the non-dense index. Why? We have only 1, 2, 3, 4 index key entries. Okay? Then,
can you repeat the difference?
Then, textbook. How many words in this textbook? A lot. So, does this index, does this index include all the word?
No.
No. That is non-dense index. if you make the index for all of this word, that is dense index. So for this, if you make the index for all the data, all the record, that is called dense index. But this one uses only 1, 6, 11, 16. That means part of the data is a non-dense index. We will see the example of dense index later. Before that, somebody may be curious. Is it really faster? The using index faster than this without using index? We don't know yet. So let's verify whether using index is faster than fast or not. Okay? To do that, we need some example database. Not data, yes, example of it. I think this one is a good example. So we create the employee table, name, social security number, address, job, salary. So suppose that, can you read that? Let record size is what? 150 on average. So let's say this is a fixed length. One record, one tuple, it requires 150 bytes. Okay, then it's a larger, the letter R. Block size. What is the size of each block? 512 bytes. And how many records? How many data? 30K. 30,000. Okay, then. Let's see. This is the information about this. What is a blocking factor? In other words, what is a blocking factor? How many records per each block? So, how many records?
5.
5?
4.
4?
6.
How many? One is 150 bytes.
5 times 150.
300. 450.
So it's about 1.
Can you add one more? No, because it's a 512. In other words, blocking factor can be P divided by R, right? And what? Flowing. Can you understand? Probably this is a 3 point something.
Yes.
Can you keep the part of that? Let's say we are going to use non-span record. The non-span means we cannot use part of them. Then this one will be 3. So blocking factor is 3. 3 means we can insert 3 data for each block. Then, how many blocks do we need? How many blocks? How many blocks?
30K by 3.
30K divided by 3. Why? We have total 30K record. For each block, we can keep the 3 block divided by 3. That's it. Actually, we need to do ceiling. Sometimes point something. That means we need the entire block. So this will be 10K blocks. So we have 10K block for this table. When you search the data, how long it takes? How long it takes? Speed. Log 2 n. That means log 2 right? What is that? Anyone who has calculator? So this is
log 2.
log 2 and this is 4 times. Is it correct? Thank you. Yes. So log 2 and log 10. This is 1, right?
Yes.
So this is 1. What is log 2? So point 3, 2, point 3 something?
3.
Is there anyone who has an advanced calculator?
Yeah,
So
I have it.
4 over log 2. So 4 over log 2. So 13 something?
Log 2 is 0.301.
Yeah, 0.301. Why don't you divide? 4 divided by 0.301. I think it's 13 something. Right?
10, huh?
So 4 divided by 0.3, just 0.3. It's a 12. What is it?
3, 4.
I think it's a 13 something.
Wow.
Right?
No, I have different number.
13 something.
30.33.
30?
30.33.
30 point. 13 or 30?
30.
1.
30.
1, 3. Right? Something.
Yes.
I already did it before. I cannot remember this.
4
Okay? What does that mean? 30. Let's say 30. On average, this is the average. How many I/O do you need to search the data? 13 I/O, 13 blocks. At least, not at least, on average, you need to visit 13 blocks. Professor asked, how long it takes? Why do we consider number of blocks for speed? Because input and output is much more expensive than other operation. So we ignore the other, just consider number of I/O, input and output, number of blocks that you need visit. That is 13 on average without using index. Then, why don't we use index? We need more information. We need more information about index. So index field size, because this size is 9 bytes. And also address size is 7 bytes. So total 16 bytes for index key entry. Okay? So let's use this one. So this is this. For index, we can do the same thing. Index size is a 16. And block